Hi guys, so today I'll be running through with you a summary on applications of integration. Today, I'll be summarizing to you the area and volume about the x-axis and the y-axis. There are some concepts here which you have previously learned in secondary school, but I'll reiterate them along with new concepts that you will be recapping today. So let's start with area about the x-axis. As you can see from this diagram here, we have a curve and the shaded region, which is the yellow color portion, is bounded by the curve x1 and x2. So let us recap what we have learned in secondary school A Math. So we will have area of shaded region equals to integrate from x1 to x2 y with respect to x. Okay, so this is what you have learned in secondary school. Now let us recap with me, okay, because I'm going to be introducing new concepts to you. If y equals f of x. Now what kind of equation is this? If I say y equals f of x, think about it. And yes, you are right, it is the Cartesian equation. Why am I emphasizing this to you? Because along with Cartesian equations, there is the presence of parametric equations in the H2 Math syllabus. So it is logical if I write integrate x1 to x2 f of x dx. So far what you have learned is secondary school. Okay, so now moving on to parametric, the idea of parametric, alright? So what are parametric equations? You have learned this in your graphing technique, so I'll just reiterate to you. If x equals to f of t and y equals to g of t. So this is the general form of a parametric equation in t. So what we need to do, if we're going to find area of shaded region of a parametric equation, we need to replace, okay, term by term. So what we need to replace the x limits with t limits. We need to replace y and dx. Okay, so let's do this slowly, okay, because this is an important concept that is heavily tested in A levels. So let's replace the y first, shall we? Replace the y with g of t. Okay, g of t. Now, because now it's a term in t, would it be logical if I write dx here? No, right? We cannot do this. So instead of writing dx, we need to replace dx with dt, okay, with respect to t. So how is that replacement going to happen? Now, pay attention. From over here, if I differentiate this with respect to t, I'll get f prime t. Agree? Now, do you see your dx and dt over here? I can actually make dx the subject of this equation and make the replacement. So what you can do is that you'll say dx is f prime t dt. Okay, I cross multiply. Okay, now this is mathematically incorrect, okay, what I've just written. So do not write this. Do this mentally in your head and do the replacement in your head. Okay, so replace the dx with the f prime t and dt. Now, what did I say about the x limits? You need to replace your x limits with t limits. Okay, so it is t1, t2. Okay, so that's how you're going to have to do it for parametric equation. Now, let's go on to another concept that is heavily tested in the A levels. It's called the volume of revolution. So follow along with me. Volume generated when the shaded region is rotated fully about the x-axis. Do note that you need to know this formula. Okay, very important. So I'm going to write it in red. Pi integrate from x1 to x2 y squared with respect to x. Okay, so that will be your volume of revolution formula about the x-axis. Now that we have understood the concepts of area and volume about the x-axis, let us progress to area and volume about the y-axis. Again, I have a curve here and it's bounded. The shaded region is bounded by the curve and the y limits, the y1 and y2. So again, let me reiterate what you have learned in secondary school. Area of shaded region equals to integrate, okay, in this case is your y limits, so it is y1 to y2, and in this case it is x dy. Okay, so in most cases you have to make x the subject of the equation, then you can proceed to integrate. Okay, so again, if x equals f of y, what kind of equation is this? Good, this is a Cartesian equation. But then again, we have to introduce the idea of parametric equation because it's H2 math. So for a parametric equation, x equals to f of t, y equals to g of t. So this is what we call the parametric. Okay, so it will make total sense from the above illustration to call this f of y dy. Okay, so then again, the idea behind parametric is the replacement. Okay, so we will replace term by term. We will replace the y limits with t limits, replace the f of y, and replace the dy. Okay, so I always like to replace the x first because it's the easier one. Okay, just copy f of t. F of t. What's next? Replace the dy. So where can I get a dy? Okay, so I think I can get a dy from here, right? Differentiate with respect to t to get g prime t. So do you see your dy? So again, do this cross multiplication in your head. Do not write dy equals to g prime t dt because it is not mathematically sound. Okay, so do this in your head. I will get g prime t dt. Then again, replace your y limits with your t limits. Okay, last concept that you have to know, again, is heavily tested in A levels, so put a star or something to remind you. Volume generated when the shaded region is rotated completely about the y axis. Again, this is a formula that you have to internalize. It's not given in MF26. Pi, integrate your y limits from y1 to y2, x squared dy. Take some time to internalize these two concepts, and this is the summary for applications of integration for H2 math. Thank you.